Hi, it's Alex Blyth here from the Exadata Core Technologies PM team. I'm going to give you a quick overview of Oracle Exadata Configuration Assistant. So what is the Oracle Exadata Configuration Assistant? Well, Oracle Exadata Configuration Assistant, or OECA, is an easy-to-use tool that models Exadata systems, and it covers performance, capacity, and environmental requirements to help you integrate Exadata into your data center. It supports on-premises Exadata database machines and storage expansions, zero data loss recovery appliance, and Exadata database service on cloud at customer. In addition to modeling, OECA can validate configurations, supports multi-rack system design, and helps you plan power distribution, again, to help you integrate into your data center environments. So what does OECA provide me with? Well, OECA provides a lot of really useful information to help you integrate Exadata into your data center. It gives you environmental information, including max and typical power usage for the configuration you've modeled, max and typical cooling requirements, airflow, rack weight, and acoustic information. It also gives you excellent performance information, in particular, analytic scan throughput from Flash and XRMM, read IOPS and write IOPS, database CPU and memory capacity, raw and usable capacity for hard drives, performance optimized Flash, and capacity optimized Flash as well. In addition, it provides advanced functionality to enable you to model multi-rack configurations, check the network cable maps, rebalance power and PDUs, import and export configurations, and create configuration-specific data sheets. Remember to always use the latest version of OECA. To download the latest version, go to Oracle Software Delivery Cloud, also known as eDelivery, using the following link. Once you've downloaded the latest version of OECA, starting OECA is as simple as going to the web directory in the downloaded folder and opening the index.html file. And you should see something similar to what you can see on the screen in your browser. Let's see OECA in action. Let's create our first single rack configuration using OECA. All right, so in this example, we're going to create a simple quarter rack, and we're going to use the latest generation Exadata X11M. So we're going to select from this drop-down our Exadata X11M database server variant. In this case, we're going to use the 512 gig database server, but as you can see, we could just as easily choose the 1.5, 2.25, or 3 terabyte, or even an earlier generation rack if we wanted to. I'm going to go ahead and click X11M 512 gig database service here. And you'll see immediately that a whole bunch of extra information has been added to OECA. Primarily, the rack is now filled out in its empty format, and we have some performance metrics that have now shown up on the right-hand side. But more importantly, we've been given the option of database server generations. In this case, we're going to choose that same 512 gig database server, and we're going to choose X11M high capacity storage. We're going to simply add 2 database servers and 3 storage servers to create what would be known as a quarter rack configuration. Now, without doing anything else in this particular configuration, you can see here a number of useful and interesting pieces of information. First of all, we automatically select for ASM high redundancy for both data and recode. That is our best practices, and we recommend that you follow that through for every single deployment using Exadata and ASM. We've also pre-populated the amount that has been allocated to data as 80%. You can go and change that if you choose to for on-premises. For our cloud variants, slightly different configurations there, more fixed configurations, but you can change that on the on-premises variant if you want to. Now you can see some other useful and interesting information here around the environment. You can see how much power from a maximum point of view in kilowatts and kVAs, the typical power, max cooling and typical cooling in BTU and kilojoules per hour, airflow requirements, rack weight, and also the acoustic noise the machine generates as well when running under that load. On the right-hand side, you can see some other interesting information around performance metrics. In particular, you can see analytic scan throughput both from Flash and Exadata RDMA memory. So that's these 2 metrics here on the top left-hand side. And then for OLTP or mission critical workloads, you can see 8K read IOPS and 8K write IOPS at a nice 5.6 million and 3 million IOPS respectively there. Next, you have some capacity information, capacity being the amount of memory, cores, the raw PCIe flash in this particular configuration, as well as raw storage for high capacity extreme flash and XT storage, or extended storage there on the next row. Then we get into our usable capacity. So usable capacity is taking into consideration the redundancy level. So I mentioned high redundancy earlier on. So it takes that into consideration, as well as the breakup between data and RECO. So high capacity data in terabytes, high capacity RECO in terabytes. You can see the usable there is 192.1 terabytes and 48 terabytes respectively. EF and XT or extended, because we haven't added any of those storage configurations or storage server types to this configuration, we don't have any metrics for those, quite understandably. At any point, you can click on this See Datasheet button down here in the bottom left-hand side, and it will generate a configuration-specific datasheet. So you can see those same metrics down here. I'll highlight them here just very quickly. You can see those same metrics down here, the capacities as well, and the environmentals at the top. So you can get a configuration-specific version of the datasheet at any point in time that you want. Now let's create a more complex multi-rack configuration. Some environments require very large Exadata deployments that span more than one rack. So to do that, we're going to create our initial configuration. So I'm going to go back to using on-premises here, and you can see all of the on-premises information that comes along with that. I'm going to add our standard kind of servers in here, database server and high-capacity storage servers. And I'm going to add a fair number of both of these into the configuration. So you can see there I'm really filling up this particular rack to its capacity. Now, you don't always have to fill the rack up before you get a multi-rack, but I'm going to do it just to show the point here. And you can see the performance metrics have been increasing there, the capacity metrics, the environmental on the left-hand side have all been dynamically changing as we've been adding those in. Now, to create a multi-rack configuration, since X8M and newer, we have to include a spine switch in every rack that is going to be included in a multi-rack. Slightly different to the way InfiniBand worked, but with Ethernet configurations, we have to have a spine switch in each rack to be able to create a multi-rack configuration. So we're going to check this include spine switch, and you'll see the spine switch is added all the way down here in RU1 at the bottom. You'll also notice that a new rack button appeared up here in the top left-hand corner of OECA. And that allows me to create a second rack or a third or a fourth all the way through to 8 racks in OECA today. Now, bear in mind this warning when you click on new rack. What this is saying is that very first page, that first rack, has all of the rules applied to it in terms of the types of servers that go in there, whether the correct number of servers is in there. It meets all of our rules. So we recommend that you always configure each individual rack as a standalone rack to make sure that the rack validity status comes up okay. If you're re-racking into your own racks, that the re-rack status also is okay. Each of the subsequent racks in OECA, when you're doing multi-racking, is really to make sure that the aggregate view of the multi-rack configuration comes together, so you can see the combined performance metrics and so forth. So that's what this alert is saying. Make sure you model each rack individually, as well as doing it as a multi-rack configuration to make sure that everything is valid across the board. So we're just going to click OK on that. And then we have a similar set of information available to us. I can create, maybe I'm going to rack this with an older rack or multi-rack this with an older rack. I can add in the configuration that I want to add here. We're just going to add some more of these. And you'll see here on the right-hand side, the performance metrics for this individual rack have been changing. Now, I can switch back and forward between the different racks using rack 1 and rack 2. I can also do the same thing here on the right-hand side. But importantly, what you'll see here is this Combine tab. And the Combine tab will, as the name implies, give you a combined view of the entire configuration. So it will show you a graphical representation of, in this case, both racks, as well as a combined set of information around the total environment information, so power, both max and typical cooling, airflow, combined rack weight, the combined acoustic levels generated by the machine. Probably more importantly for most users of OECA, you want to see what the combined performance metrics are, though. So you can see the scan throughput from Flash, from XRM for the X11M servers, the read IOPS, the write IOPS, overall capacity, both memory, Flash, database cores, and then capacity obviously as well. I've only got high capacity in this configuration, so EF and XT are understandably set to 0. And then the usable capacity as well. I haven't done anything with the redundancy over here on the left-hand side for either of the racks, so I'm getting high redundancy across the board. But you can see that if we change those on rack 1, those numbers dynamically change as well on the combined tab. The other thing that you'll want to be aware of is the network button that comes up here. When we're multi-racking together, we have to connect these racks together. So the network tab that becomes available when we're doing multi-racking allows you to see how many different cables you need to be able to interconnect these two different racks between each other, and gives the field engineer a map of how to connect those spine switches and leaf switches together to enable multi-racking. I'm not going to go into detail here, but this is obviously a good way of understanding the requirements around the number of cables that you need and what kind of cables, including the part number, as you can see there on the right-hand side. But more importantly, once you have all of those cables, how to connect each of these up. And your FE, your field engineer, will be able to guide you through that part of the process. Let's return now, and I'll give you an overview of the OECA UI. So this is the main panel of the Exadata Configuration Assistant, OECA. First of all, on the top left-hand side, you'll see, obviously, the name of the product, but more importantly, the version number. We do add capability and refine capability in OECA on a regular basis, so please make sure you're always using the latest version of OECA. Next, you can see here information about the rack. Now, the rack is an important selection because it tells OECA a lot of information about what the configuration is going to be capable of. First of all, whether it's on-premises, whether it's a cloud, a customer, or a recovery appliance. But it also tells OECA important information about how we cable each individual rack. And you'll see here that there are a number of different rack selections, in particular for X11M and X10M on-premises, and the cloud variants of those as well, because the different amounts of memory have different cabling and different power requirements, power being the more important of these factors. So choosing the right configuration in OECA is important to make sure that you are configuring your machine correctly or configuring your deployment correctly for the kind of workload that you're going to be running in there, and then understanding the implications around environmental requirements inside the data center. So just as an example, I'm going to choose this 512 gigabyte configuration for 2-socket. But as I said, you could just as easily choose 8-socket, one of the older 8-socket generations, recovery appliance, the zero data loss recovery appliance, or a cloud variation as well. But I'm just going to stick to on-premises here to make it relatively straightforward. You can see there's a lot of extra information that gets populated at that point. Most importantly, you can start choosing which type of database server and which type of storage servers you want to add into there. Just because you've chosen a rack of one specific type doesn't mean you cannot add a database server with a different memory configuration. It just changes the way, or it impacts the way that power cabling and power distribution in particular is done inside the rack. It's not an exclusionary, it's just it's an extra piece of information OECA uses and needs. So I could choose a 1.5 terabyte configuration database server. I can choose different types of storage, so high capacity Z, X10M, 8th rack. If you scroll down here, you'll see the different types of storage. So there's extreme flash, and then we get into the extended storage towards the bottom as well. I'm just going to choose high capacity to keep things relatively straightforward. And I can toggle the number of database servers and storage servers, and you'll see metrics on left and right of the rack, as well as the rack itself being populated with servers, changing dynamically as we're adding those different database and storage server configurations into the mix. You can add additional database servers, either of the same generation or of a different generation. Maybe I'm doing a combined configuration here. I'm going to move some older X10M database servers into this rack. And I could add some additional storage. I'm going to add some Extreme Flash, X11M Extreme Flash storage servers in there. And you'll see that they're all populated on the fly or dynamically, as I said before, and change the environmental information as well as the performance information at the same time. The other thing to point out here is a couple of big green bars in this particular instance, but the re-rack status and rack validity status. So some customers use their own standardized racks in their data centers for whatever reason that happens to be, whether it's power, cooling, distribution, security requirements. Maybe they're in a colo and there's a standard rack that colo provides and requires customers to use. It's important when you're modeling an Exadata in OECA, if you're going to re-rack that Exadata into a non-Oracle rack, that this re-rack OK button lights up green to make sure that that's a configuration we can allow you to re-rack into that third-party rack. It's very important to do that to make sure that there's no friction or no challenges in going down that path. The other piece of useful information is this rack validity status. Now, this really comes down to a configuration that we're able to configure in a factory or grow into over time. As you can see here, there's multiple generations of storage and database server in here. But this will give you an idea of whether something you're doing is not going to be supportable by Oracle were you to try to put that together. Something like adding an InfiniBand database server and a Rocky database server in the same configuration, those two networking technologies are incompatible, so that would be invalid. Now, we've got rules that don't allow that in the first place, but that's probably the best example that I can give you of something that would come up as invalid. Another, I guess, point to make just around that validity status is if you were to try to do something as simple as adding the wrong number of servers. So at a bare minimum, we require 5 servers in an Exadata configuration, 2 database servers and 3 storage servers. This is simply telling you that you're missing something in the configuration. So adding that second database server in will solve that problem there as well. So just an example of how rack validity works. So a few quick points to make on the UI. In particular, these OECA actions you can see at the bottom left-hand corner of the panel. Now, these allow you to, or 2 of these options that we're going to explore very quickly here, allow you to effectively set a restore point or a save point in the work that you're doing inside the browser, or export a configuration to a file that you can then load back into OECA later on. So let's explore both of these separate. So I'm just going to quickly create a configuration, just nice quarter rack on premises here. And this local I/O is really browser I/O. This is browser memory that we're working with here. So I'm just going to save this. And now there's no dialog box or anything of that nature. Like I said, this is browser memory. So I'm effectively creating a save point for this configuration. And then maybe what I want to do is I'm going to add some more equipment to it. And I'm going to add some X10M EF. Maybe I'll add something else in here as well, some X9M HC. And I'm going to add another database server in here. Let's add some X10M. And I've created a configuration here that, I might be perfectly happy with. Maybe this is what I want to do. But really, I'm going to try a different scenario. Maybe I want to add some different storage servers in there. I'm consolidating a number of different machines together. or I just want to see the performance profile of different pieces. But I'm going to start again with that quarter rack. Rather than refresh the page and add that back in or remove each of these, which I could with these minus buttons, I'm just going to load that configuration, that restore point that I had just a few moments ago, so that quarter rack. And it really just resets OECA back to that point in time so that I can go, I'm going to start with that quarter rack, and now I'm going to add in 3 terabyte database servers, that same generation, and I'm going to add in some extreme flash, because really this is what I want to build out in my environment, is this configuration of a mixture of different memory configurations for X11M and 2 different types of storage for X11M. So it gives me a quick way to go back and forth to load and save. So save being create a restore point, load being go back to that restore point. Now, the other thing that you can do is what we call external I/O. So this is what you would think of saving and loading from a file. So I can export, save this to a file. So I'm going to give it a file name, Alex's Exadata Config. So I've saved that out, and you can see there that it's saved to a text file. I can close that. And if I wanted to refresh the entire environment and then load that back in, I can import that back in, choosing from a file, be it my downloads, so Alex's Exadata Config, load that back in, press import, and then you can see I brought that back in. Now, that's a really useful piece of functionality, because oftentimes myself or my other Exadata PM colleagues or our development organisation, specifically the folks that manage OECA, will ask for that config file to either validate what's been done or possibly debug an issue that maybe someone raises with OECA at some point in time. So just be aware of those 2 different options. Local I/O, think of that as an in-memory restore point that you can create and then flash back to. If you use database terminology, an external I/O being saved to a file and load from a file. Nice and straightforward for you there. Now we'll take a look at some of the more advanced functionality OECA has to offer. All right, every now and then, customer data centers require slightly different configuration or slightly different power draws for a number of different reasons that I'm not going to go into in detail here. But one of the capabilities of OECA is to enable you to remodel or change the way that power is distributed inside Exadata to the different database servers and storage servers in your configuration. So I'm starting here with a simple quarter rack, as you can see, 2 database servers and 3 storage servers. And just notice here that I've got 3-phase 15 kVA PDU. Now I can click on this Show PDU Details radio button, and it'll actually give me a map of where each of the database and storage servers is plugged into. So green receptacles here associated with storage servers, these slightly red ones, the database servers, and the yellow are the switches. Now, in this case here, you can see that I've got power distributed across all 6 groups inside both of the PDUs on the left and right-hand side of the machine. But the data center that I'm working with may ask me to use less receptacles or draw less power across that entire PDU or set of PDU groups. So I want to rebalance by going to the PDU menu, rebalance all of the power and see if we can find a different solution to our power requirements. So sometimes that can take a little bit of time, sometimes it can be very quick. In this case, we found a solution. And so if I check OK here, I can choose to view a report of the cables and where they've moved to, but I'm going to do that in just a second, coming back to that PDU menu, and I'll show you the same report. I'm just going to close out of this though, and hopefully what you can see here is that we've effectively rebalanced all of the power from across the PDU or all the way up and down the PDU as we saw before to effectively the bottom half of the PDU on both sides. So you can see that we've balanced or removed those. Now, I said a moment ago that there was a report that's generated as well. This view cables option here shows you effectively the rearranged or the new cable layout that you need to, or that your field engineer needs to be aware of. And you can see in this case, there's a lot of 3 metre cables now required versus the 2 metre cables that were in play in the first place. But your field engineer can help you work through what that would be, what that or the rebalancing of power would result in. In summary, OECA simplifies configuration, design and validation of Oracle Exadata engineered systems. It provides clear visibility into the system environmental requirements to integrate into your data center, along with performance capacity capabilities for on-premises Exadata, storage expansions, zero data loss recovery appliance, and Exadata database service on cloud at customer. And this helps you move from design to deployment much more efficiently. Thank you for your time.